All right, we're back. All right. It's crunch time. I fixed some of the things. I figured out the kernel thingy, but I guess what's going on? Memes here. Time for round number, I don't know, 12 or something like that. I need to crank out the rest of these calculations. And then I need to start actually writing up my whole outline into an actual narrative that's somewhat engaging and stuff. So, all right, let's get back to it, shall we? We shall. Let's present that at the time screen. Boom. There we go. All right, let's get Rulio. There we go. All right. So where are we? Okay. So elementary lengths across the universe. We had. Okay. So we're going by the elementary lengths across the universe. Okay, how do we do this again? We did. I believe it was. Okay. So it was. Hold on. It was Hubble time by Planck time. Enable dynamics. Alright, then 2 times 10. Alright. So let's just double check here. So time, do we have unit? Okay. So we need 2 of that. All right. Because it's just going on in one direction, so we need to length across the total thingy. There we go. Double time. All right. This guy here. All right, so in regard in regards to the number of elementary lengths across current universe. Just do number of elements across the universe according to the Wolfram model. It's calculated from the Hubble time, which is big 8. Oh, hold on, wrong thing. H naught. Divided by the Planck time, small t sub big P, multiplied by 2 to get the diameter because we're doing that. That would give radius. Diameter times the square root of big psi. And then multiply. Is that the right way to do it, though? Hold on. Let me just make sure. As long as we're close, but... Okay, Hubble time divided by the Planck time will give us a dimensionless number, and then we should just multiply that by the Planck length. Alright, so... Oh, actually, you would just do C. Speed of light. Okay, that gets the Hubble length, and then... Oh, it's the Hubble length. Hubble length divided by Planck time. No, length. Sure. Gives the same number. Okay, that's fine. That's fine. Everything is fine. Multiply by the square root of capital psi. Okay. Pod. This seems prettier. Oh my god. Wow. Okay, let's just do this one at a time. Oh god. That's why we can't have nice things. Ah, come on, give me something better. Okay, there we go. All right. Save. So that's what we're supposed to do. Okay, and then we do take our number. Boom. Square root. This dude. Let's run this stuff. Okay. I I mean, I don't need all those ones. Just need one. There we go. Two, three, four. All right, so. All right, plane. Oh, we needed to do two. Derp. So wrong. I don't. Ugh. Those are the little things that get me. It's like, all right, so I gotta put all these nines in here. Why? Because we can. Okay. All right. So now we got our factor of 2 in there. All right. That makes it. All right. Boom. Those guys there. All right. That evaluates. That evaluates. Oh no, it goes right there. Derp. Okay, there we go. Much better. All right, so let's go elementary lengths across the universe. Here we go. Cross current universe. Okay, we fixed that stuff because there was also a little squiggly in there. It's like a little question mark thingy. Okay. Estimate. Yeah. All right. Okay, so yeah, we're about 3 orders of magnitude. So yeah, because they're putting that in there. Okay, file, save. Oh, we should do save as, shouldn't we? Okay, see, that's the thing. Sometimes it will put that there. That's what's confused me so long. It just randomly will save it as a notebook, but I'm sure that has something to do with my causal doing. Save to cloud. All right. I apologize if I'm not being so active because I'm just the crunch is setting in. It's like, oh god, it's been so long. Things that I haven't worked on in a while that I'm like, I should probably do this. I'm gonna force myself to finish this. Long story short is after I do this stream, I'll probably do it. I'm not gonna actually have another session. I'm just gonna focus and just go, just because I realize, even if I'm not really paying attention, there's part of my brain that is literally just like, oh my god, wait, there's some people here. I need to be an entertainer or something. Yes. Where is the fun? Oh no! Oh no! Well, have they tried dividing by 0? That's a great question. Let's do 1 divided by 0. Well, we return to complex infinity, so I guess you win, Wizard. Yeah, that seems to check out. Oh my god, yeah, the rounding errors. Oh, jeez. No, I haven't worked it a little bit before. I need to get really back into it, so I digress. Hold on. I'm gonna turn up my anime music a little bit, just because I like it. I'm sorry. I know it's not feeding through, but hey. Son Goku, please save me. All right, so we got that. All right, so our estimates there. Elements of spatial hypergraph. All right. Okay, where the heck do we get that 10 to the 184? I have no idea where that comes from. Crap. I need to search the book, don't I? Elements in spatial hypergraph. All right. Oh, jeez. Spatial. I spelled that wrong. Spatial. Did I spell that wrong? Okay, so 414. Oh, we're just over there. What's our standard calculation for that? Okay, that was... I didn't see any numbers or anything there. 43. All right. Did we calculate this here? Spatial. Okay. Okay, yeah, I mean, that yeah. Lashman suggested to be within an octet is notable the total number of elements in spatial art is estimated to be more than 10 to the 200 times the number of elements of all known particles in the universe, especially in a sense of a computational effort is expended on the creation of space rather than the dynamics of matter as we know. Oh. Length and time now must be quantized. Where elementary lengths. Okay. Quantum electron, the current price is assumed to have zero intrinsic size. A large number of elements that just be when it is. Okay. Where the heck do we get that? Okay, I think it might be time to ask ChatGPT. Because I have not read this whole thing. Or at least the entire book here. Okay, hold on. Generational states. I looked through this yesterday. Yeah. Estimate other quantities. Elements in spatial hypergraph. Huh. Alright, Wolfram. Physics. Elements. Spatial hypergraph. Was it in the structure of space chapter? I was literally just looking at this. Maybe I... That like, half a paragraph you don't read. You just glance over. Okay. Okay, so this is an... Okay, I'm pretty sure this is an estimate. Okay, so I think they did a log thingy for this. Ordinary manifold. It's okay. Where reach a scalar, value this curvature. Okay, so they're modeling a via cylinder. Okay, we've got into the P tensor fields and the Riemann tensor. So yeah. Let's check Jonathan's work. Okay, so I think it's looking like a lot of this work is literally Jonathan's, or he may have, because a lot of this is what's there. Okay, how about this? Let's do the cheap thing. What's the number there? 184. This is terrible. 184. Let's search. 184. Damn. Let's 184th power. Let's go. Perhaps. Okay. Okay. The elements in the spatial hypergraph is that. You're going to multiply that by 3 halves. Where the heck are we getting 184? 10 to the 26. Oh. Oh, this could be crazy. Let's do this. Okay, 10. Okay, so the 184. This is terrible. 10 is to the 26. I'm just curious. No. No, it can't be. I just have to remember how the heck I got to it. Intensity, H bar C. Okay. It's 122. 122 to 158 is 10 to the 26. Times like energy. Oh, no, no, no. I got it from the flux. Okay, hold on, hold on. So 1 over Planck length squared Planck time. I literally multiply this by the Planck power. Is that what it was? Planck power. Because if we do... Is it force? No way. Okay, that's 158. That's 150. What the heck is this? Power density. The number of elements. Well, that should be just a dimensionless count. That's... What the heck am I multiplying this by? Length of the observable universe? Let's do radius of universe. Okay, how about this? Hubble length. There we go. Hubble length. That's the term. Okay, we're within 1 order of magnitude. I have no idea what the heck any of this stuff means. Oh, this just became energy flux density. Oh, God. Okay, I don't know what that is. Alright. Pass. I should have done that a while ago. Okay, so... estimate. That's spending far too much time on that. That's just a wild guess, just of knowing some magnitudes. Or being able to ask Wolfram alpha about magnitudes. Alright. So... Alright. Of elements. Spatial hypergraph. Okay, a lot of these things are talking about the causal graph, so, okay, causal branchial. Okay, no. We're using the branchial thing to kind of weave things together. Okay. So, that... Okay, so I don't have that, so, but we can go through here. And then we have elements in the branchial graph. It's just literally this. Oh, edit. Want the cell. Okay, plug our cell in there. Format face button. So if that's the number of elements, okay, so right now, according to this framework, the elements of the branchial graph will allow for the flux of energy and momentum. Because when we take that number, that 10 to the 112 versus that 10 to the 116, that's basically, we're just... I mean, again, probably nothing, but if that's what it is, how did he know? How did he know? Like, to even go about all this is just... Literally, hey, I'm literally just a monkey with a magic typewriter and an idea of where to look. That's literally people, smarter people than me are like, here. Magic typewriter, what does this say? Blah. Okay, We've hypothesized that the number of elements in the branchial graph, just big psi, big psi may have direct correspondence to the Planckian dimension of flux, which is meters raised. Oh, hold on. Hold on. Oh, come on. Why is it exponents? Well, just let me do that. I'll save because, well, duh. Okay. Okay. Using a, for example, right? Okay. Yes, yes, the power function. No, I just want it to look nice. Okay, I don't think it matters. Raise to the -2. Seconds, raise to the -1. Yes, I'm literally just throwing this here. I'm so terrible. There we go. I have an exponent now. -1. Oh, I'm so bad. I'm so bad. What did I do? Oh, wait, hold on. It's -2. Meters. Oh, why won't you let me delete these things? No. Wow. Should have just done this. No, -2. It's an area flux. All right. Okay, we got it. That took far too much effort. Yeah, normally you just do the plus thingy with the control or something. go. Okay. Save. Oh, God. Why is typesetting such a horror? Hey, Tommy. Yeah, no, I'm just, yeah, no worries, no worries. It's, no, I'm just struggling here for basic typesetting. Hey, Bill. There we go, there we go. All right. One man past monkey and his friend Son Gogeta. See, I was always more of a fan of Vegito personally, but that's a matter of personal preference. Personally. Okay. God, that was a lot for things that I'm already saying. The Planckian dimension of flux. Seconds. I really just need to do this, don't I? So let's do. Alright. Now, if I literally just throw this in here. Alright. Will it understand the exponents? Just because does it? Wow, it's taking so long. My kernel's about to crap out, isn't it? Oh. Okay, so let's do this. File. Save. Thank you. Alright, so. Length. So -2. Where the heck did that come from? Like time, erase that, -1. There we go. Boom. Okay. So, okay, they're doing none. I don't know why I'm complicating that. I should just do what I normally do. Then again, it's just that I just do 1 over it. I don't know why it's saying none. Here we go. That's much better. God. Always try to do something different. Try to be, oh, let's do something impressive here. Blah, blah, blah. Alright. Okay, we have all our dimensional stuff. Boom. Okay, we should have all the stuff we need there. Alright. So we got that. That goes with that. And then insert interpretations. Looks length. Alright, cool. I mean, God, wouldn't that just beat all if literally being pointed in the direction of flux. The actual elements of the branchial graph correspond with the Planckian, the Planck flux. Oh, and that just beat all. Again, highly speculative. But it is fun to entertain an idea. Alright, so the elements in the branchial graph. Overall updates are coming from our... Okay, so that would be that number divided by 2 then. Okay, so overall updates. Alright. So we need our overall updates. That's gonna go here. Okay, and then we need this dude. I have no idea how to get that. So it'd be square root of that. Okay. So that's Hubble time divided by Planck time times the square root of that. Alright, so... Save. Cool. Alright. Oh, gee. Oh, Bill, that's hardcore. I can't say I haven't done similar things, though. So, what am I going to criticize? It's, no, you just pay attention to what's interesting to you. Alright, so elements in the branchial graph, overall updates so far. Okay, so... Okay, so I just put in estimate. Let's try to make these things generic format. Alright. Save. Alright. I need to do this so I can actually do the other important things, so. Okay. Let's see. Well, hopefully at least I'll have this interpretations and stuff done, so. Alright. Alright, the over updates. Alright. Estimate the overall updates of the universe thus far. Where was that? We used we use our same calculation, Hubble time divided by the Planck time. We use the first part of our earlier calculation. For number of elementary lengths across our current verse. The Hubble time H naught divided by the Planck time. multiply it by the square root. And multiply by the square root of big psi. Somebody on Twitter was saying, anybody that uses big psi as notation, like, they deserve a very special place in hell. And I respond to her, and I'm just like, this is part of my summer school project. She's like, why? I'm like, hey man, I did set the notation. Finding a good notation can be hard. I just thought it was ironic as I literally see this. It's like, whoever does this is like, well, welcome to my summer program. All right. Where are we? Scanner the big psi. Okay, so let's save before my kernel conks out, because, well, why wouldn't it? All right, so let's do this. I mean, I could just code all this stuff in here, couldn't I? This seems like a lot of work. So we already have that. All right, so we're literally just gonna do this. Don't mind me. Copy. God, the rounding. Oh, I'm sorry. It bothers me. All right, output. There we go. Okay, got that. All right, so we're within a couple orders of magnitude. Okay, so, all right, so 2 orders of magnitude, not too shabby. The update number of updating events in you. No idea. No idea the amount of time. Yeah. I mean, I could. Yeah, it's gonna take too long. Maybe I could figure out something, or somebody can comment on how I could get that. I don't know. How would I put for the other one? Number else? Nope. Question. Okay, I can ask somebody else about that. Alright, so... no. Inquiring. Wolfram Alpha, save me! Alright, where did I put that? Oh, it's literally this guy. There we go. Copy. $245. That has to be. Don't think about it. I'll go down another rabbit hole and I'll. Okay, how about this? Individual updating events in the universe. So far, no idea. Okay, so file. Save as. See, it just changed the name. Wolfram. Flux units. 7, 6, 2025, 3. Oh man, sorry. Oh. Sorry. Ah. The amount of mental stuff that's going into that. I'm probably gonna regret drinking that much coffee. That's okay. It's okay. We'll be okay. The summer school director, she's like, it's fine. It's fine. Everything's fine. She gets it. She gets it. It's so good that Professor Wolfram has something like her because it's literally like the living, like that little dog that's there. There's fire everywhere. It's like, it's fine. Everything is fine. I'm sorry. It's been very fun. Okay, what am I doing? All right, we went through those thingies. Yeah, I'm not even gonna touch particles. That will drag me down so many Wolfram holes. Okay. Again. How did he know? You're looking at this. It's like about 10 to the 52 watts. That's a power unit. That seems large compared to a typical astrophysical process, but one could imagine it being relevant for a larger merger of galactic black holes. Okay, so and again, this is just crazy. The level of intuition here. It's like, hold on, 10 to the 52 watts. What the heck is that? 10 to the 52 watts. Voltmeters. Wait a second. What's the one thing it's in the range magnitude of? Oh, look. It's Planck power. I don't know. I don't know. It just... Dang. I mean, literally, this was calculated by, like, different method. Like, it's kind of going the same method, because elementary time and, okay, elementary energy divided by elementary time is going to get you power. Like, if you do the Planck thing easier, you're going to get the Planck thing there. And if it's the same ratio... Okay. And GeV per second, yeah. I mean, at this point, I don't even know, like, if this is surprise. Like, should I be really surprised? Should I be like, whoa, mind blown? Or should this just all be obvious? Part of me, I'm in a little bit of all the camps here. I don't even know what's going on anymore. Well, to be fair, I never knew what was going on, but that's a personal problem. Okay, so that was square. That's square root. Okay. So let's do energy and momentum. Okay, so that was force, that was force, that was force. Okay, okay, okay. Oh, jeez. The mental amount of energy that I'm using. So obviously, like, I calculate the speed of my internet minus length of my videos. I'm still back. I have no idea. Like, I understand. I think you're in the part where it's like you don't really have like the high speed internet. You have to use DSL or something. It's just, wow, dude. I'm sorry. All right, where are we? Welcome back, Dan. Back again. Look who's back. Tell a friend. Numbers are like a box of chocolates. If only they could go on forever. The number of elements be so much larger. Okay, so I think that kind of goes to the question of initial creation or something. You gotta start with at least somewhere, so I think it's positing that you you had some Eames or something. I mean, I have my own speculation, but I still can't get something from nothing. It's just I need at least an infinite dimensional Hilbert space, a configuration space, random waves, or invoke the Ruliad. It's a very useful thing to invoke, just because it's like, well, if you're gonna have all possible rules, eventually you get some rule set that might stick. Literally, how some of the one of the corporate sales projects I was running. It's like spinning with the VP. It's like, listen, we'll literally just throw crap against the wall and see what sticks. It was an honest answer. Total energy a ton. Okay, wait. It's all ratios. Kepler always has been. I think Julian Barbour had said, what is it? He said on his tombstone he wants nothing but ratios. Here's the thing. XYZ, like, that's my general MO. It's like, all right. I personally happen to be a fan of maximal extendability and nothing but ratios. Math works and logs are useful. Those are my general axioms, so to speak. And then from that, hey, model away the best we can. Okay, the ultimate ratio pi. Ooh. I mean, it is hard to argue with pi. Although cheesecake may take you up on that, even though cheesecake has crust, which technically seems to put it in the category of pie. Fizz pointed this out to me. I had a much more elaborate explanation, but hers was much more direct and to the point. At least, see, that's the interesting thing some places, because it's like, I do something called asymptotic analysis, at least in my mind. Like when I was in high school and you do the graphing calculator thing, and you're like, all right, get this asymptote, what's it do? It like goes all the way up and it never quite touches, but still infinitesimally going over, and then the other one goes the other way, and I'm like, all right, what is the maximum way this could be? What is the minimum way this could be? Just literally take it from one end to the other and generally assume it's probably somewhere between those. Now, that's a very naive thing to say, but I feel like it's good if you're trying to set up a particular argument about something, because there's different magnitudes of different stuff and the things they do. Okay. So, in this case, so we should be able to calculate the maximum energy and momentum. Okay. Okay, how do we do this? How do we do this? Because I know how we do in Planck units. It literally should be the exact same thing, because this is going to give me this is going to give us the speed of light. Okay. Well, let's just do it. So what do we need? What do we need? We need... Okay, so if we take the square root of our elements... No, not the square root. Okay, let me do it up here first. I'm sorry, this is just how I best know how to do things. Okay. So file again, save. So we have to be anal. Alright, so 1 over Planck length squared Planck time gives us our dimension of flux. If we multiply by the Planck energy, okay, we get the Planck intensity, which is a measure of energy flux density. So it would be. Oh, it's probably just going to be. Hold on. That times the elementary energy? No, I need to divide. No. That's a lot of mega electron volts. Oh! What is that? Sorry, now I'm nosy. Okay. So, the Planckian relation. Okay, so it looks like inverse of our estimate of elementary length. Okay, so. Oh, you just literally just do the same dimensional thing that I just did. Okay, so that's going to be elementary energy divided by the elementary length squared times the elementary time, right? Okay. Let's see what the heck happens. Oh my god! The number is so ginormous! Wait, was that one of the thingies there? 250 something, 250-ish. 245, okay. Is that what it is? 234. 245. Okay. Okay, that appears to be the energy flux density for the entire graph. That number is just. I don't even know. I got nothing. I got nothing. How many Planck intensities is that? It's probably just times big psi. It's got to be right. Wait. If we divide it by 112, or take a. Let's try it. Wait a second. Let's put a 1 here. Oh, that's why. In order to normalize it, do we need this dude? Oh, that made it far worse. How do we get to it through these units? Okay, here's where I'm trying to get to. Multiply Planck energy, you get, looks like maximal energy flux density. If you multiply by the Planck momentum, we get the Planck pressure, aka that's the Planck density. But if you were using bosons or stuff like that. Oh, jeez. Okay. Unfortunately, I think I'm going to have to take a break. Because this is becoming a slightly more difficult. I just don't want to. I can just reverse everything that we did, but that's not following the methodology. You want to follow a logical, coherent methodology. So, okay, so if we have 1 over that, let's go back. Okay. Big ginormous number. All right. Well, I'll go until at least this Godzilla Final Wars song finishes. Why? Because it's awesome. All right. What dimension do I need to get to? That's probably a good question first. Okay. So, mass, time. Okay. So I need to take mass, energy, so that means I need to divide 2 dimensions of length and 5 dimensions of time. Okay. Let's do it. Divide by. Oh god, this is some of the most haphazard BS I've ever done. 5 dimensions of time. Jeez. Raise to 5. Oh, we broke it. We broke the computer. Normalize machine precision. I'm not looking for that precision. Okay. Oh, we need energy. Okay, so we need elementary energy. There we go. This should neutralize some of the bigness. Okay, it didn't help that much. A complex infinity! Well, we just divided by 0, my friends. Oops. Oh. That might help. It helps if you actually have something doing something logical. Okay. I mean... give it a space? Okay, screw it. Turn the message off. I don't care. Oh, God. Okay, I'm taking a break. I'm sorry. I'm sorry, guys. I guess at least something for that. Why does that look familiar? Energy per area. Tell me more. Okay, sunburn units. Alright, alright. I need to go grab myself a smoke, folks. I'm sorry. Smoking is terrible, but right now my stress level is increasing and I need some more nicotine. So, we'll do this file. Save to cloud. Because we like clouds. Hold on, are we normally just saving? File. Okay, it's already saving in the cloud. Alright, cool. Alright, let's quit that out so I don't have a Wolfram kernel maybe running the whole time. Alright. Let's see, what do we have here? Let's see, the least energetic, I think it was brute force core processing. Well, at least according to the physics project, like, so much of the computational resources are basically doing literally just rewriting or updating stuff and things here, like literally, quote-unquote, free space, but as far as we know, like, free space seems to have some energy associated with it, which, aka no true vacuum. I don't know. Is the vacuum Irish? I'm part Irish. I think I'm allowed to say that. Never mind. All right. I think that's going to be all for tonight because I literally just need to brute force through this and actually do some narrative stuff so I can actually have something useful to submit. So, other than that, hey, peace out to everybody. Take care of yourselves. It's a wacky and wild world out there, and it's open for another tomorrow. Oh, yeah, and happy belated birthday, America. Peace out, everybody.